Welcome, everyone. This is the Liberty Classroom course, History of Economic Thought 1, Classical Economics and the Marginal Revolution. I am your instructor, Robert Murphy, and we are now on Lecture 18, Leon Walras. So if you're following on the PowerPoints, you're going to be in good shape. If you're not, let me just warn you, I'm going to go through the majority of the lecture, and it'll be fine. You can just listen to me speaking it. But at the end, I'm going to walk through a numerical example of a Walrasian economy, very simple one, of course. And for that, it's going to be tricky for you to follow that part of the discussion if you're just listening. But you could get by with just skipping that. However, if you really want to understand Walras, then obviously you're going to want to get the PowerPoint out and watch me walk through the particular example at the end. Okay, so Walras was 1834 to 1910. Some biographical remarks. He was born in Normandy in France, graduated from the University of Paris. He was in letters in 1851 and then science in 1853 in terms of his study. His father was Auguste Walras. He himself was an economist, though obviously not nearly as famous as his son would turn out to be. And several accounts I read argued that it was from his father that Walras gained his appreciation of a focus on utility when it comes to economics. All right, so remember, Walras is one of the three economists credited with ushering in the marginal revolution. And so what does that mean? Well, remember, it means that he focused on marginal utility, even though I didn't use that phrase, as the way of understanding the relationship between preferences and market prices and so forth. And the claim is that Walras perhaps benefited from the French tradition. So remember, there was this, at least two separate lines. We talked about this in an earlier lecture, where the French economists developed along different lines from the way that the British classicals did. And so, remember, Murray Rothbard, for example, thought much more highly of the French tradition than of the British classical one. And I'm saying here that that view, not necessarily that one's better than the other, but when it comes to understanding Walras and why did he stumble upon or discover marginal utility theory, using modern terminology, they'd say, well, he had an advantage there because of the strong tradition in the French line. Okay, Walras dabbled in engineering school. He didn't actually finish that degree. He was in journalism. Apparently, he wrote a romantic novel. Here, I'm relying on Blaug's description. And then he worked as a clerk for a railroad even. Now, in the year 1870, at this point, Walras was 36. He became professor of political economy at the University of Lausanne. And that so that came to be known as the Lausanne School. All right. So just as there were different schools of thought, this was the tradition that Walras himself set up, so it was associated with formal mathematical models of the economy. And his successor in that post was Pareto. So we're not going to talk about Pareto in this course, but if you take the second half or second installment of my History of Economic Thought course for Liberty Classroom, we will definitely hit on Pareto. You may be familiar with the term Pareto optimality. So that's due to him. And also there's what's called Pareto's Law that has to do with distribution of income. And that's another sort of famous thing that we attribute to Pareto. So as far as back to Walras, the hands down the most important things that he wrote were his two volumes of Elements of Pure Economics, the first part of which was published in 1874. So remember, we talk about Menger and Jevons and Walras all simultaneously and independently discovering marginal utility theory. Walras was the latest into print with it in 1874, but it's an interesting story. He was sending letters to the Jevons, and it was clear that Walras really did independently discover it. It's not that he read Menger or Jevons. Okay, so what was his contribution? As I say, Jevons, Menger, and Walras were all discoverers of the marginal utility approach, but nowadays, looking back, the real innovation or pioneering contribution of Walras, also especially since he came in 1874, so if he hadn't written anything on marginal utility theory, it wouldn't have been lost to humanity. But his big thing was the fact that he didn't merely discover or write about the determination of price via marginal utility analysis, but instead the real thing that set him apart from his predecessors, in which nowadays mainstream economists would say, oh, wow, look at that. He was really ahead of his time and really anticipated the development of the field, is the fact that he had a formal model of the entire economy. All right, so what he was doing was writing out systems of equations that characterize the entire economy, as opposed to just like saying, oh, let's picture this guy over here who's got some horses to trade and this person over here who's got some eggs to trade, and let's figure out what the egg-horse price ratio is going to be. That's not what Walras was trying to do. He was trying to build an entire framework by which you could analyze the entire economy in one fell swoop, and that is what people think of now when they think of Walras, not that he happened to also have discovered marginal utility analysis along the way. So the way you describe that typically nowadays is you would say what he gave us was general equilibrium analysis. All right, so he would give general equilibrium models of the economy. And for example, when I went to NYU, I took a class on general equilibrium theory. And if you're saying, well, what would not be general equilibrium? Well, the tradition of Alfred Marshall, which is probably, if you've taken any economics classes, that's what you probably studied, I'm guessing, unless you went on to grad school. That would be what we would call partial equilibrium analysis. Okay, so for the purposes of this lecture and Liberty Classroom, we don't need to get too much into the weeds here, but the difference is partial equilibrium analysis looks at one market and it isolates the effects of a change in price or a tax or something like that, a regulation, as it impacts one market. So you might have supply and demand curves in that one particular market, like the market for gasoline. What happens if the price of crude oil goes up? And you say, oh, let's look at what happens in the gasoline market. And so you'd say, oh, well, the supply curve shifts left because crude prices are higher, and so it's harder for refiners to make gasoline, so the supply of gasoline shifts left. And then what effects does that have? And you walk through it. So you're mostly looking at the impact of a stipulated change in one particular market, and you run through that analysis, but you don't then say, okay, now let's take into account the feedback mechanisms or the ramifications that this change is going to now have as it ripples out through all the other markets in the economy. And so when I get to Alfred Marshall, who's going to be the last person we cover in this course, this part one, we'll talk more about this, the distinction between general equilibrium versus partial equilibrium analysis. So I think it's probably safe to say, I think most economists would agree with me, general equilibrium analysis is more correct, right? You're not going to miss anything if you do that. If you look at the whole system in the beginning, then you introduce whatever the stipulated change is, you let the entire system reach a new equilibrium, and then you can compare and contrast and say, okay, what change in the entire economy happened because of this stipulated change? And that's fine. The problem is that's really difficult to look at. First of all, you got to come up with a model of the entire economy. So if you really want to say, well, what's going to happen if crude prices go up, and I want to know the impact that that's going to have on the market for iPhones in Boise, that's, wow, are you sure? Do we really want to get the model that's that comprehensive? So the virtue of partial equilibrium analysis is you hope you can kind of hold other things constant and look at just that one market and figure out the brunt of the changes and hope that if you then allowed for the feedback effects and the ramifications as it ripples out elsewhere, it wouldn't negate your answer. So at least you'd know the direction in which the change is going to occur. So that's, again, we'll go over that again when we get to Marshall, but that's why, even though I'm saying, I think most economists would say general equilibrium analysis is more accurate or correct in some metaphysical sense, I guess, nonetheless, economists often don't use it. Most of what you would see economists doing in any particular application is partial equilibrium analysis. Now, let me make this point. The Walrasian system, it's micro in the sense that it looks at all the individual markets and analyzes them in perhaps exhaustive detail, but don't then conclude that, oh, okay, so we can only look at, quote, micro things. No, if you know what's going on at the individual level of each person, each household, each firm, each commodity market, if you know all those particulars, well, then you can step back and also talk about GDP, or you can talk about, what's the output of an entire sector if you know what each firm in each sector is doing, or you can talk about what are aggregate wages if you know what each individual worker's wage rate is and how many hours each worker supplies in equilibrium. You just multiply them together and add them up. And so don't be fooled by that there is this unfortunate divide that we have in economics where we talk about micro versus macro. And that divide is largely coming from the Keynesian revolution. But if you have a certain view of how the economy works and you have a general equilibrium model, well, then when you solve that model, you can talk about anything you want. You can get down and say what the price of apples in Boise is, or you can talk about what's agricultural output, weighted by the money prices or something. So the reason I'm mentioning it, because I've often thought that, and then I saw Schumpeter when he was talking about walras made that point as well, that even though walras, someone characterized it as a micro theory, it's so powerful that he's doing the whole economy, and so therefore you can give any macro statistic you want if you have all the little building blocks. Whereas you couldn't go the other way around. If all you have are macro relationships, you have some aggregate supply, aggregate demand curve, then you can't, if that's what you start out with and that's the equilibrium you derive, you can't then break it down and say, oh, okay, but what are the prices of apples? You say, I don't know. I just got two curves that intersect. I don't know what apple prices are. So it's easier to go from the micro and aggregate up, whereas it's impossible to start from the macro and then break it down into a level of higher granularity. Okay, so what are the components of the Walrasian model? We have what we might call exogenous variables. So, think of like an exoskeleton that's like a skeleton that's outside. So exogenous variables are ones that are just coming from outside, like they're just being given to the analyst, as it were. All right, so the person creating the model is just picking these things. These are just given facts of the universe. So these would include the utility functions of the consumers, or you might call them households, the initial endowments that the consumers or the households and the firms own at time zero, if that's the way you want to think about it. And depending on the model, this could get pretty sophisticated. So it could be consumer goods that they start out with. It could be durable consumer goods, things like refrigerators that provide a flow of services. It could be natural resources, like you could have a copper mine or something that starts out with a certain amount in it, and then if it gets mined over time, then the amount carried forward to the next period is smaller. You could have inventory that the firms are holding, so previously produced goods intended for sale but that have not yet been sold, and so they're carried forward in inventory. And you could have capital equipment, tractors, machines that are inside the factory, and so forth. So it's not that any particular model in the tradition of Walras is going to have each of these items, but the point is, Walras, when he was describing his framework, was showing the types of things that could be in the model, right? So he was just showing the power of this approach. And the other thing you would want to put in there is the production functions that the firms possess, right? So that the transformational rules saying this firm, if you put in a certain amounts of various types of inputs like labor hours and gasoline or whatever, then what shoots out of the firm in the form of output goods or other types of goods or possibly services. Then you also have what are called endogenous variables. So these are the things that are not given at the outset in terms of the structure of the model. These are things that are determined by the analyst. So they're affected by the exogenous variables, but these are things that you calculate. They're not just given at the outset. So here, in particular, what you're going to compute, if you will, or try to find are the prices associated with each particular market, and then the quantities demanded and supplied in each market based on the particular price that's prevailing. And so given that setup now, in equilibrium for a particular Walrasian general equilibrium model, a specific equilibrium occurs when you find a vector of prices. So vector is just a fancy word meaning like a list. So you have a price for each of the markets, and so you find a whole list of those prices or a vector of prices, one for each market, that equates the quantities supplied and demanded in each of those markets. All right, so the equilibrium, again, to fully characterize it, if you've got this formal model, you have to give me a list of prices, one for each of the markets, and then it has to be the case that for each particular price in that specific market, the households, when they figure out how much of that good do they want to buy at that price, and then the firms, when they figure out how much do we want to sell in that market at that price, those two numbers have to be equal. And that's got to be true for all of the markets. So if we have that, that's an equilibrium situation. Now, given a listing of the exogenous variables, we can ask, does equilibrium exist? It might not. It's possible you could go set up the model and then demonstrate there does not exist a set of prices that would cause all the markets to clear. For a market to clear, that's meaning the quantity supplied and demand that is equal in that market. All right, so you can ask the question, does equilibrium exist? You could also, if it does, you could also then say, well, is it unique? All right, you can have examples where, given the same exogenous variables, there are multiple equilibria, right? So there's not just one set of prices that causes equilibrium, but there's multiple sets. And the equilibria could be different too, right? So it's the quantity supplied and demanded in each market could be different based on which particular equilibrium we're in. And then another question to ask is, for a given equilibrium, is it stable? And so here what we mean is, yes, by definition, if there's an equilibrium, it means if those particular prices, the list for each market in the whole economy, quantity supplied and demand is equal in each particular market. But what if we tweaked it and just made each price either go up or go down by 1%? What would happen? Well, we would no longer be in equilibrium, right? Quantities supplied and demanded would now be different, presumably, in at least some of the markets because the prices moved. But would forces nudge prices back towards the equilibrium level? Or would the forces that would be set in motion cause the economy to, veer away and go somewhere else. So here, the way to think about it in terms of a physical analogy is imagine a marble that's on a hilly surface. Okay, and so if the marble is at the top of a hill, that's an equilibrium position, right? A stationary marble at the top of a steep hill, right? Like, so you're imagining that it goes up and then down. So the marble's poised at the top, and as long as it's not moving there, okay, it's an equilibrium. All the force is all balanced. Gravity's pulling down. The normal force of the ground's pushing up. The marble's not moving. But if some little force perturbs it just a little bit, you just nudge it a tiny little bit so that the marble's no longer perched perfectly on top where it's in equilibrium, it starts rolling one way or the other, it's going to go faster and faster down the hill, right? So that original spot, even though it was in equilibrium, was not stable. In contrast, if the marble comes to rest at the bottom, in the canyon, then, where it's like there's a U shape in terms of the terrain and the marble's sitting at the bottom, that is in equilibrium also. If the marble is motionless at the bottom there, it will stay motionless, so it's in equilibrium, but it's also stable. If you pushed it a little bit one way or the other, it would quickly come back to that original equilibrium position. All right, so that's the distinction. So we're not talking about marbles and a terrain and gravity, of course. We're talking about a vector of prices and the associated responses of firms and households. But the idea is that when you figure out how do firms and households respond to any particular price or vector of prices, then you figure what the equilibrium is. Then you can ask, if we change those prices by epsilon one way or the other, then how do the firms and the households react? And with that, when we figure out what does that do to the prices in the next period, does it move them back towards that equilibrium, or does it push them further away, perhaps towards another one? Okay, let me now talk a little bit about the pros and cons of Walras's formalism. So one of the good things is that, I would put it this way, that his formalism, and when I say formalism, what I mean here is that his insistence that to do really rigorous analysis, we can't just write in words, that we have to come up with equations and characterize the economy and model it using math. All right, so that's what Walras's whole enterprise was here. So I'm saying there is a benefit of that. He correctly characterized marginal utility, or at least he understood the importance of marginalism in economic analysis, whereas that had eluded the classical economists, people as brilliant as Adam Smith and Hume and Ricardo. And he went beyond that. In later editions of his book, Walras actually had a very sophisticated understanding of the fact that really what you're pricing in the marketplace is a flow of services. And so a lot of times the two are indistinguishable, the flow of services and the particular physical item that yields them, if it's something that expires right away. So if you buy a pizza, you could say, well, what's the difference between the flow of services that the pizza provides and the pizza itself? That's not really that big a deal, right? Because you eat the pizza and the services, the period over which the services are consumed is pretty short and the pizza's gone, right? So whether you're thinking in terms of, wait a minute, am I actually buying a pizza or am I buying a flow of consumption of pizza-ness? That's really a distinction without a difference. But if instead you're talking about farmland, well, then obviously that's a huge difference. And so what you're really, the more fundamental building block is to say, how do I use marginal principles to understand the pricing of land rent? That's the more fundamental thing, to say the use of this land for a period of time. How do we figure that out? And then once we know that, and we can, look forward over a certain time horizon and figure out the pricing that land will give us in terms of its services each period, then we can say, all right, so right now, how much would I pay for this plot of land to own it outright? And that involves looking at that flow of future rental services and then discounting them to the present using the interest rate or interest rates if they're going to change. All right, so that's a very sophisticated area of economics that really was not fully fleshed out. We're going to see Bombaverick did an amazing job in defining the problem and clearing away fallacies. And then most economists would say that people like Frank Fetter and then Irving Fisher in particular perfected it and, systematized it. And that's not going to come for decades more. And so while Ross was able to really see some of these subtleties, and I would argue it was because the formalism of his model kind of left him no choice, right? You can't commit a fallacy inside a logical mathematical model. The model might be completely unrealistic, and maybe if you assume away certain things, you're going to trick yourself. But you can't have a contradiction inside the world of the model, right? That's one of the things that doing something formally guards against. And so I don't think it's a coincidence, or it's not surprising to me that while Ross was able to really isolate the correct way to think about how do you apply marginal utility and then marginal productivity theory to factors pricing, and he realized it was, well, actually services were the more fundamental thing, and then he just capitalized to figure out the price of durable products or factors, that you kind of, it clarifies your thinking to do it mathematically, put it that way. So let me just try one more shot at this to make sure you get the point. As you're going to see in 2 lectures from now, we're going to start Bombaverick, and we're going to start walking through some of his famous refutations or critiques of other theories of interest. And it's not that Bombaverick had access to some empirical data that previous economists lacked. It's not that he conducts experiments. No, he just thinks through the issues and then realizes, wait a minute, their explanation doesn't make sense because think of it like this. Or maybe he'll do a thought experiment. But the point is, he just is using his mind to analyze the problem from a certain perspective, and he's showing, using a clever analogy or just a way of describing a scenario, he gets you to see, oh, wait a minute, these previous thinkers were arguing in a circle and they didn't realize it. And so the reason that happened, the reason that was possible, was they were writing in words. And so they were arguing in a circle. They said something that looked compelling on the surface, and it took someone with the incisive analysis of Bombaverick's mind to pierce the fallacies. So what I'm saying is, well, Ross, I don't think was nearly the economist Bombaverick was, but he was able to hit on the correct way of looking at some of these problems because he set out to do it formally. And once you put it in terms of math, you can't argue in a circle, if you will, or it's going to be obvious that you are doing that. So that's the great advantage of formalism in economics or elsewhere, is it sort of keeps you honest, I'll put it that way. So now that I've given a nod to the benefits of formalism, I think the other points that I'm going to say on this particular topic are all going to be downsides of it. Okay, so a huge problem is if you're going to make a model of an economy and just start writing out equations that all have to be true in equilibrium, and then you go ahead and you, quote, find the equilibrium, you don't have any causality, right? You can't say, where did this market price come from? So like an Austrian might want to say, oh, market prices are generated by or are caused by subjective preferences and, human action. And that's what causes market prices. Strictly speaking, in a Walrasian model, that type of language doesn't even mean anything. He said there is no cause and effect in these models. It's just I can start writing statements that have to be true in equilibrium, and then I can find you a set of prices that satisfy those conditions. And that's what I mean when I say I have characterized an equilibrium. It doesn't make sense for you to ask me, okay, but what caused that price of tomatoes there? What do you mean, what caused it? Another huge problem, of course, if you're going to do a mathematical model of the economy, is it's just a model. You haven't actually explained how prices in the real world are formed. So Carl Menger, will recall, he didn't think he was making a model of the economy and then he was solving the model, hoping to shed insight on what happens in the real world. Menger thought he was finding the actual laws of cause and effect that are applicable in the economic realm. So another way of putting it is, Menger and the Austrians who followed in his tradition, they were trying to explain real-world market prices. In contrast, people in the tradition of walras, they build a little model, and they totally understand how things work in that model, and then it just we're supposed to then perhaps draw lessons from that to gain insight into how the real world works. But they're not even attempting to actually explain the real world. Now, in particular, this issue of, well, how does the economy attain an equilibrium set of prices? We can characterize the economy by these equations, and we know what an equilibrium vector of prices would mean. Now, what process does the economy go through in order to approach that equilibrium or to reach it? So here, Walras did understand the problem, and he came up with this famous device of saying there's this auctioneer who just yells out prices. And then the people in each market decide or reveal how many units they want to buy or sell at that announced price. And then the auctioneer looks at everything, and if there's an excess demand, that means the price was too low. And so next period, he raises that price. And vice versa, if there were an excess supply, that means the price was too high. And so he lowers that price. And so each period, he keeps tweaking the price, the vector of prices, depending on what the response was last time. And that is called a tâtonnement process, by which the economy, through trial and error, gets closer and closer to equilibrium, we hope. So there's problems with that. One thing is that's not how the market actually works, or at least only in very contrived settings would it work like that, like maybe some particular auction, like a literal auction hall and so forth with a guy up there with a microphone. But in general, that's not how the economy works, right? You don't find yourself walking through the grocery store and people yelling out prices. And also, there's a certain logical difficulty in it, that people don't actually trade at those prices, at the false prices. Right? Strictly speaking, the auctioneer announces the prices, and if it's not equilibrium, oh, wait a minute, nobody trades anything, and then he tweaks the prices, and then again checks to see, did we hit equilibrium yet? So there's problems with that, one of which is, do the people in the model know that that's actually what's going to happen? Because then might they not think strategically and realize, oh, wait a minute, so it's, the way the model works in terms of Walras justifying the procedure, the people honestly report what they would do. It's like the people keep being fooled. They keep thinking, this is it. This is the real price. Now here, I want to buy 5 apples because this is the price. Oh, I actually get to buy 0 apples. I got to wait because that wasn't a market clearing price. Okay. Oh, now the price is, okay, now I want to buy 6 apples. Oh, man, I can't believe it happened again. right? So the idea is the people are acting stupidly. They don't understand the model in which they live. That I guess one way of putting it is the model itself actually doesn't have that tantamount process in it. The model just says, here's the equations, and then can we find a price vector that satisfies all of them simultaneously? And then we're sort of on the outside saying, now how can we kind of tell a story to justify us saying the economy we think is going to be close to this equilibrium in the real world? So there's that sort of back and forth between what was actually in the model and the story we're telling to justify our use of the model. Okay, another one that here, this is a bit of a subtlety, but it's a pretty big problem, is what you're going to find in this example we're going to walk through here at the tail end of this lecture. The power of the Walrasian approach is that you can see everything in one fell swoop. You're like I guess you could say God looking down, or let's say an angel to be less heretical, looking down, or I should have said blasphemous. That was the word I was looking for. So you're like this angel looking down on the whole economy, and you can see everything at once. You see all the equations or whatever. And so in that mindset or that framework, you can make any of the goods serve as the unit of value, the unit of market value. So you can pick any one of them and just say that's the numeraire. That's what numeraire means. That's the good that's going to be our standard of value, or a standard of wealth, if you want to put it that way, against which we measure all other market values. Okay, so don't worry here. We're not committing a problem of assuming utility is cardinal, even though Walras does use cardinal utility functions. Talking about numeraire, that doesn't commit a fallacy of cardinal utility, in case you're aware of what that would mean. So don't worry about that. That's not what I'm saying. What I am saying, though, is if you pick apples, for example, and say we're going to set the price of an apple to 1 by definition, and then measure all other prices in terms of apples, okay, yeah, you can do that in a Walrasian system, but there's really no reason to have money. All right, you're just really what you're doing with the Walrasian system is you're computing the barter exchange ratios that will hold an equilibrium. You're figuring out how much does each good trade directly against another good, an equilibrium. And there's no reason for anybody in the model to trade everything against money first and then use the money to go buy something else. Now, you can do that formally if you want. If you want to just pick one of the goods and say, oh, this is money, you can do that. But it's a bit contrived, I'll put it that way, because in the model, like you looking at the model, you can see everything at once and you can compute all the price ratios. So you know all the price ratios. There's no reason for you to first turn everything into money. Now, if you're looking at the PowerPoint, you'll see in parentheses I said using this approach makes economists think of things in terms of a barter economy, and then they just lay money on top of that, thinking of it as like a veil, as an afterthought. And then in parentheses I have regardless of Walras's intentions. All right, so I was reading Schumpeter on this, and he was very sympathetic to Walras, saying that, a lot of people, when they criticize him, they give him a bad rap and so on, and that Walras really did intend to work money into the system, like a true money, with all the complications that brings into play, as opposed to just grabbing one of the other commodities that was doing something else that people were consuming directly and designating that as a numeraire. But what I'm saying is, regardless of what his intentions may have been in practice, people who work in the Walrasian tradition are solving for equilibrium barter price exchange ratios. And you can just define any particular, you can pick this good as the numeraire, or you can choose this good over here as the numeraire, and that will just, you'll have to recalibrate all the prices, but the same underlying real exchange ratios are going to be the same. So let me put it to you this way. What the Walrasian system gives you is it's showing you an equilibrium how much each real good trades against each other real good. So you know how many stagecoaches trade for a horse. You know how many apples trade for a banana. You know how many acres of farmland trade for a ton of steel. And those numbers are going to be the same regardless of whether steel is the unit of value or horses or oranges. The specific numbers of, so the price of a horse, the number is going to be different if the unit of value is oranges versus gold coins. But what I'm saying is when you ask how many horses trades for an acres of farmland, that number is going to be the same. And so economists in that tradition then tend to think of the economy as a set of barter relationships, and they don't understand the importance of monetary calculation. Okay, so it is very hard for modern mathematical economists to understand Mises's point about the problem of socialism, because if you have a Walrasian model, socialism would work. Well, I mean, the calculation problem doesn't exist, put it that way. There could still be problems of incentives and evil people just, doing bad things when they get too much power. But the Misesian problem of economic calculation in a socialist commonwealth, if you're an economist used to dealing with a Walrasian general equilibrium framework, you're not going to see the problem. You're going to say, what are you talking about? People can still calculate, we just list the vector of prices, boom, boom. And in fact, that's famously what the market socialists did say in response to Mises. All right, so I'm getting way ahead of ourselves here, talking about stuff that we're not going to really study until the next sequence in this course. But I'm just trying to explain to you the danger of this Walrasian approach, even though it's quite beautiful and elegant in one respect. Nonetheless, you start working with these models, and this is what I learned at NYU. All right, so I graduated from there in 2003. So I was there from 98 to 03. At that late stage, we were studying Walrasian models of general equilibrium. I mean, they might not have called it that, but that's what we were studying. And again, my classmates, they would not be able to understand the Misesian calculation problem. They would think that wasn't a problem.